Hello, everyone. Thanks for joining and welcome to the session today. This is going to be our day one and beyond security series, and we're going to take you through various topics and different activities related to building out on Oracle Cloud. Our session today is going to cover OCI connectivity options, the solutions and services that are available today within the cloud, what we have planned out, and some advantages that customers have and how easy it is to get started building out in the cloud. We're going to go through many different gateways. I'd like to introduce our presenters today. We have Sean and Ashita.
Hey everyone. So my name is Sean Moore, and I'm here with my colleagues Ashintya, Shojit, and Anya. I'm one of the many principal network architects here at Oracle, and our team's goal is to essentially help our customers understand, implement, and support the wide range of networking features available in OCI. So today we're going to cover OCI private network connectivity options to help you understand how to connect to and from your current or future workloads in OCI. Correctly architecting and deploying these constructs are instrumental for building the framework needed to ensure you have expected network performance, reliability, and reachability to your resources located within OCI. All right, so for the session, we will assume that you already have foundational knowledge of OCI virtual cloud networks and its related networking resources, such as the various gateway types and security capabilities. If not, please be sure to view one of our previous day one and beyond sessions that covers these foundations or our official OCI documentation. For today's agenda, we're going to start off with covering how to establish connectivity between virtual cloud networks, also known as VCNs, within our out within or outside, an OCI region, with the use of our gateway constructs listed here, followed by a quick demo with an example of using the local peering gateway, which I'll talk about next. We'll then walk you through the various options for connecting to private networks external to OCI, such as to your on-prem environment or even a different cloud provider. All right, let's get started. So we'll start with the simplest connectivity method that provides connectivity between VCNs within a region to communicate with each other. This is known as the local peering gateway, also known by the acronym LPG. The local peering gateway allows for a one-to-one direct connection between two VCNs within the same region. A local peering gateway is provisioned within each VCN, and the LPG is then paired with the neighboring VCN's LPG. So once that's established, each VCN can use routing rules in their respective subnet route table to reach the neighboring VCN's network via its local peering gateway. So as we see in this example, we have two virtual cloud networks, or VCNs, with two different CIDR ranges, VCN1, VCN2. Within each VCN, they also have a local peering gateway deployed inside of them. And by using the VCN subnets route table, we can directly communicate between the two VCNs via its own local peering gateway. So while this provides a quick and easy solution for establishing connectivity between the VCNs, it does not scale well with larger OCI networks that needs to connect multiple VCNs. So if a VCN needed to communicate with multiple VCNs, a dedicated LPG would need to be provisioned for each VCN it needs to communicate with because it is a one-to-one connection. And that's only up to a max of 10 neighboring VCNs. So a better solution is to use our dynamic routing gateway construct, which we'll talk about next. Okay, so the dynamic routing gateway, also known as DRG, is an OCI network construct that provides scalable private network connectivity outside of a VCN as well. Note that the DRG is not associated with any single VCN. Rather, it is a standalone object, logical object, provisioned within the region itself. So this gateway provides private connectivity between VCNs in a region, other OCI regions, on-prem locations, and even other cloud providers as well. It supports IPSec VPN, FastConnect service, which we'll talk about, and remote peering connectivity options to other private networks. So every connection to a DRG is called an attachment, and a DRG can support hundreds of attachments, and this is what lends to its scalability. Each attachment is associated with its own route table on the DRG, but this route table can be shared across other attachments as well. We can also use custom DRG route tables that can be created with static or dynamic-based routing configuration, and this will allows it to provide great flexibility on controlling routing between the different private networks. Note that a dynamic routing gateway can scale up to 300 attachments, so that's quite a bit more than an LPG can do. But an attachment can only be connected to one single DRG. So as an example, a VCN attachment can only be attached to a single DRG. In this example, as you can see in the screen here, again, we have our virtual cloud network or VCN. This VCN has the subnet with the route table. Note that this VCN will like to communicate with our customer's data center environment located down here that's also attached either VPN or a FastConnect service to this dynamic routing gateway in the middle. So the dynamic routing gateway, again, it isn't a part of a single VCN. It sits in a region. It's a logical construct. But with the attachments that we have between the VCN and the on-prem environment, we can now establish communication between the VCN and our on-prem. All right, so the final gateway construct we'll discuss today is called the remote peering connection, also known as RPC. Remote peering connection is a process of connecting two DRGs together via the OCI backbone. So the RPC isn't a gateway itself, but rather a dynamic routing gateway feature that allows backbone connectivity between the different OCI regions. So this is typically formed between OCI regions for use cases such as disaster recovery or inter-region data transfers. And as mentioned with the remote peering connection, it's created on the DRG itself, and the peering relationship is formed with the neighboring DRG. So in our example here, we have two VCNs, this time in two separate regions, region 1 and region 2. The VCNs are again using the DRG for connectivity outside of its own VCN, but this time with the use of the RPC that's paired with the other DRG across the way, we're able to establish bidirectional communication across the two VCNs in the different regions that we have here. One of the big requirements that we really have with this is to avoid overlapping CIDRs at all costs. That's kind of the best practice, no matter how you build these out. But essentially, this will prevent any type of routing loops in this type of scenario. Okay, so before we move forward to some of our private connectivity options that we have that allows us to create networks outside of OCI, we're going to head over to the OCI console, and I'll provide a demo on how we can quickly establish connectivity between two VCNs within a region using that local peering gateway construct. So what we're going to do in a demo is we're going to have two VCNs, VCN A, VCN B, and we're going to peer two LPGs together within these two VCNs. And from there, we're going to create route rules in each VCN subnet to use its local peering gateway as the net hop to reach a neighboring VCN network. Then after that, we're going to verify connectivity because I'll have two instance VMs deployed in each of these VCNs. All right, so let's begin. All right, here's my console. Note that I have VCN A and VCN B. Also note that, once again, the CIDR blocks, they are not overlapping. In this scenario, I do have the instances up and going already. So what I want to do is just check to see if I have any type of connection already between the instances deployed. And as you can see, they have a ping command going, one in VCN A, then have another instance in VCN B. Also has a ping command going, no response at the moment. So to resolve this, the first thing we're going to do is create a essentially a peering between each other through the use of provisioning a local peering gateway within each VCN. So I'm in VCN A, in a list of different gateways. The one I care about is this local peering gateway at the bottom. Select that. I'm going to give it a name. I'm going to call it to VCN B. All right, that's all we need for that. I'm going to create local peering gateway. From there, I'm going to go over to my other VCN. I'm going to do the same exact process. Go to gateways, head down to local peering gateways. All right, give it a name here. This time I'm going to call it to VCN A, create local peering gateway. So we have our LPGs in each VCN, but now we need to peer them together. So that's an easy process. Put these three dots here, establish peering connection. And within my region, I just simply select the VCN I'm looking for, the neighboring VCN, which is VCN A, because I'm in VCN B. And then I'm going to select the LPG I'm peering to. And after a few seconds, it will change from a pending tablet to a established state in a second here. Give it a couple of seconds. Okay, it's peered. Next step is we'll set up routing between the VCNs to complete connectivity. So I have route tables that are applied to the subnets themselves. I'm going to click on this route table, starting in VCNB. I'm going to go to my route rules. I'm going to add a route rule that's going to target my local peering gateway that I created within the VCN. I'm going to provide the neighboring VCN CIDR block. Okay, before I can add the route rule, I need to also select my local peering gateway there. Click Add Route Rules. And then perform the exact same step in my other VCN and VCNA. Okay, routing. There's my route table. Route rules. Once again, I'm going to add a route rule. Target my local peering gateway to VCNB. Select that. Put in the neighboring VCN's destination CIDR block. Okay, now I'm going to head back to my instances and let's see if we have any type of connectivity. And sure enough, we do. So we're pinging in one direction from our VCN A instance. I'm going to head over to our VCN B. The same thing, we have bidirectional communication there as well. All right. So at this time, my partner Shinta will step in. He's going to go over some private network connectivity options, and I'll have him take it away.
Thank you, Sean. Hi all, my name is Achintya, and now let's discuss about the different connectivity options available in OCI. OCI supports three cloud connectivity options: public internet, VPN Connect, and FastConnect. Relying on public internet depends on various factors like bandwidth, latency, and performance. We will be discussing the site-to-site VPN option as a private connectivity method. Site-to-site VPN provides an Internet Protocol security connection, which is IPSec between your on-premises network and your virtual cloud network. The IPSec protocol suite encrypts IP traffic before the packets are transferred from the source to the destination and decrypt the traffic when it arrives. So there are three routing types that are available, and you can choose the routing separately for each IPsec tunnel in site-to-site VPN. We have BGP dynamic routing, we have static routing, we have policy-based routing. In BGP dynamic routing, the routes are learned dynamically through BGP. The DRG dynamically learns the routes from the on-premises network. On the Oracle side, the DRG advertises the VCN subnets. Static routing: when you set up IPsec connection to the DRG, you specify the particular routes to the on-prem network that you want the VCN to know about. You must also configure the CPE device with static routes to the VCN subnets. So CPE stands for Customer Premises Equipment, and we'll be discussing about it shortly. And when it comes to static routing, the routes aren't learned dynamically, and you have to place a static route to know about the other device route. Next, moving on to policy-based routing. When you set up the IPSec connection to the DRG, you specify the particular routes to the on-prem network that you want the VCN to know about. You also must configure the CPE device with static routes to the VCN subnets. This table gives an example like how we can have the route management handle when we have static routing, dynamic routing, and policy-based routing. So which supports HA, so you can have static routing via multiple tunnels. If you'd like to have dynamic routing via BGP, so you can have native failover. And for policy-based routing, it is always custom failover. Some use case example for static routing is you have a small office network and you have a startup that you're doing. You can go with static routing. If you have enterprise WAN or hybrid cloud, you can go with BGP. And you'd like to have app-specific routing or traffic segmentation or engineering, then you can go with policy-based routing. Moving on to customer premises equipment. The term customer premises equipment, which is also known as CPE, is commonly used in some industries to refer on-premises equipment. When setting up the VPN, you must create a virtual representation of the device. OCI calls this virtual representation of a CPE. The CPE object contains basic information about your device that OCI needs. A single CPE object public IP can have up to 8 IPsec connections. So here is a list of verified equipment vendors. So if your vendor device or software version is not in this list, your device might still work with OCI site-to-site VPN. Please go through this documentation for a generic configuration of supported phase 1 and phase 2 parameters. So in a single site-to-site connection created, so 2 tunnels are created for redundancy. So if you have a single connection created for site-to-site VPN, by default, OCI provides you 2 tunnels for redundancy purposes. So you can make use of both the tunnels in case one fails or Oracle take it offline for maintenance. So CPE behind NAT. So if you have a security device in front of your customer premises equipment, so how can that site-to-site tunnel be configured? So we have the CPE IKey identifier, which is the Internet Key Exchange identifier configured on the on-premises end of the connection that must match the CPE IK identifier. By default, Oracle uses the CPE's public IP address, which you provide when you create the CPE object in Oracle console. However, if a CPE is behind a NAT device, the CPE IK identifier configured on the on-premises and might be the CPE's private IP address. So while defining, you can define the private IP address and then create the connection. Yeah, so the next topic is FastConnect. FastConnect provides an easy way to create a dedicated private connection between your data center and Oracle Cloud infrastructure. FastConnect provides higher bandwidth options and a more reliable and consistent networking experience compared to internet-based connections. So the benefits of FastConnect is consistent connection for critical applications, lower cost than other hyperscaler clouds, multiple connection options. So we have the speed starting from 1 Gbps to 10 Gbps, 100 Gbps, and newly we have launched 400 Gbps ports, which we can support with FastConnect. Using Oracle Interconnect for Azure, a specialized FastConnect offers in select regions. So this is the OCI data center topology for FastConnect. So there are 2 or more FastConnect locations, sometimes called points of presence or POP, and also formally called as FastConnect data center. Each region has 1 or 2 physical entry locations. The FastConnect, also called as POP location, is the entry point into the OCI region. The POP location is where the customer will establish connectivity to. Also, each POP location has redundant hardware. This architecture represents a traditional OCI region with diverse POP location and redundant hardware. Oracle recommends you using the diversity and redundancy built into the OCI region to build a resilient solution. Also note that some of the regions might have just one FastConnect POP locations, but you would be having two edge routers for router redundancy. Then we have the Oracle Service Network, which is also called as OSN, and it is designed to host Oracle services on OCI that have publicly reachable endpoints, such as Object Storage, Autonomous Data Warehouse Cloud, Oracle Analytics Cloud, Oracle Integration Clouds, and so on. Next, what do we need to have the FastConnect established with? So the first important thing that we'd like to have is a virtual circuit. So virtual circuit is an isolated network path that runs over one or more physical network connections to provide a single logical connection between the edge of your existing network and OCI. Each virtual circuit is made up of information shared between you and us. You could have multiple private virtual circuits to isolate traffic from different parts of your organizations or to provide redundancy. So we have public peering and private peering. So private peering is your extending your existing infrastructure into VCN, for example, to implement hybrid cloud or a lift and shift scenario. Communication across the connection is with IPv4 private addresses, which is RFC 1948 range class A, B, or C. Public peering, so to access public services in Oracle Cloud infrastructure without using the internet. For example, object storage, the Oracle Cloud Infrastructure Console and APIs or public load balancers in your VCN. So communication across the connection is with IPv4 public IP addresses. Without FastConnect, the traffic destined for public IP address would be routed over the internet. With FastConnect, the traffic goes over your least physical connection. So we have three methods when implementing FastConnect. The first one is with Oracle Partner. The second one is colocation. And the third one is third-party provider. So with Oracle Partner, you can connect to Oracle through an Oracle approved FastConnect partner like Equinix, Megaport, BT. So we have 90 plus partners in different regions. So there is a list which provides the list of partners to a particular region, and you can use them for having a FastConnect establishment with partner. So the typical use case for a partner would be you would like to have low latency, high bandwidth private connectivity without managing the physical circuits. Then we have FastConnect colocation, which is also called as direct connect. So you have your own router in an OCI FastConnect location. So you set up a dedicated physical connection directly to Oracle's network. So your data center and Oracle's data center is hosted by same data center. Then all you need to do is plug a cable from your edge routers to OCI's edge router. So here you can have direct private connectivity to OCI. Then moving on, we have the third-party provider. So this options comes into picture when you don't have the option of a partner or we don't have a partner in that particular region and co-location is not an option. So using your existing network service provider to establish a private link to OCI, this model allows you to extend your MPLS or other private WAN circuits into OCI. This is not restricted to Oracle's partners list, more flexibility for those with existing telco contracts. Great for enterprises already using global WAN MPLS and wanting to extend that to OCI without switching providers. So which fast connectivity options would take more implementation time and how complex it is or easy it is what is being discussed here. So with Oracle Partner, you can have the implementation is pretty quick and it is easy to establish. It does not have complex setup and it is easy to establish the connection. So moving on with colocation, the time is short and it is easy to establish. With direct third-party provider, the time duration is long. The reason is the third-party provider or the ISP you're using, they'll need to establish the physical cable to one of OCI's FastConnect location, also called as the POP location. So that would take a bit time. And for co-location and third-party provider, so LOA is a must. So LOA stands for letter of authorization, an official letter that provides written authorization to connect to another party within a data center. This letter includes specific information about where a circuit should be terminated to a telecommunications carrier or other end parties interconnection environment. A LOA is required to accurately and efficiently configure co-location or third-party method. So with OCI, we have FastConnect security options. So we have MACsec and we have IPSec for FastConnect. So MACsec provides the following benefits to your FastConnect. So with MACsec, which is media access control security encryption for Oracle Cloud Infrastructure, MACsec is available for 10 gig, 100 gig, and now even it supports 400 gig as well. FastConnect direct single connections or link aggregations rule in all commercial and government regions. So this is supported only by direct method, which is the co-location method. You cannot have a MACsec enabled in partner method. So having MACsec, you can have line rate encryption, data confidentiality, data integrity, data origin authentication. So IPSec or FastConnect lets you set up site-to-site VPN with secure IPSec tunnels on FastConnect virtual circuits, thereby providing added security to what is already a private connection. These IPSec tunnels protect network-to-network connections on layer 3. I'll be handing it over to Sean, continue with multi-cloud connectivity options.
Thanks, Ashant. Yeah. Okay, so our last section will be over the multiple types of multi-cloud connectivity options that we have. So essentially with OCI, we have the option to use either our FastConnect or VPN services to create direct connections to other cloud providers. And this helps create the framework necessary to build those best practice multi-cloud architectures. So let's look at how this is accomplished. Okay, so the first option we have is our IPSec VPN service. And so this can be used as a low-cost, easy-to-understand option for creating a direct and secure connection to another cloud provider over the internet with no third party needed in between. Many other cloud providers also offer their own IPSec VPN service. And in such cases, it's usually possible to establish a cloud-native connection between both sides of the VPN tunnel. So OCI has official documentation on how to establish these type of use cases with certain cloud providers. So some of the pros with going to IPsec VPN, the biggest one is probably the lowest cost option that we have available to you. It's typically easiest for all of us to understand how to use IPsec VPNs. It's a well-known service. Again, OCI has documentation for most other major CSPs on how to set this up between us and other cloud providers. And again, no third party is involved. But some of the cons to that is that performance is best effort because after all, it is going over the internet. So there's no SLAs with this particular connectivity from the OCI side of things. It's not scalable. It's a one-to-one IPsec site-to-site connection. So if you need to connect to multiple CSPs at once, you need to set up multiple separate IPsec VPN tunnels. And there can be egress charges as well. If you go over our currently 10 terabyte a month threshold, there could be egress charges for this type of connection. So with that said, For better performance and reliability, we recommend using our FastConnect service to establish multi-cloud connectivity whenever possible, especially for production workloads. So while more costly, this solution provides the SLAs and predictability that's typically needed when running production workloads between two cloud providers. So like many of our FastConnect partners, such as Megaport and Equinix, support this design, which can be configured by standing up two BGP-enabled circuits in between the CSPs through the FastConnect partner. With the FastConnect between OCI and the partner, followed by another circuit between the partner and the cloud provider using a private connection. This comes up with the solution here. So with this architecture, you can also extend it further between just the CSPs. You can also create additional private connections back to your on-prem as well. So this reduces the complexity needed to privately and securely connect to both CSPs from on-prem or vice versa. Okay, here we have an example with Megaport Cloud Router connecting AWS to OCI. So here we decided to use our OCI FastConnect service and AWS's Direct Connect service. Note that Megaport here in the middle is using their own virtual cloud managed router called Megaport Cloud Router or MCR. And this is essentially establishing two separate BGP sessions between both CSPs. You see that there. And note that with all three of these different vendors, they all have their own AS path number, essentially. So with this and with the layer 3 BGP relationship with Megaport, Megaport can not only receive routes from both CSPs, but it'll also advertise those routes as needed between the two of them. So yeah, once BGP is established successfully on both sides, you'll have an end-to-end solution between both CSPs as needed with whatever bandwidth metrics you want to have set and SLAs to support that. Okay, so I'm going to bring Ashinthia back in, and he's going to cover some of our multi-cloud interconnect services that we have.
Oracle worked with partners to create a dedicated private cloud-to-cloud connection between Oracle Cloud Infrastructure and Microsoft Azure or Google Cloud Platform in certain regions. These connections let you set up workloads where the traffic uses private, least FastConnect to carry the traffic between these clouds without going over the internet. So we have interconnect between Azure and between GCP. So the pros are, so you don't need to have a third-party provider. So earlier, without this interconnect, so if you had to connect to Azure and you'd like to have higher bandwidth and lower latency, the option was to go to a partner like Equinix or Megaport and do multi-cloud as an option. But now we have a dedicated connectivity between Azure and Google with OCI to avoid this partner. No ingress egress charges in either provider, collaborative support model, lowest latency options, lower cost than using a partner. And the only con we have for interconnectors, it is only available in specific regions. So you can accelerate application migration and modernization by combining Microsoft Azure or Google Cloud and Oracle Cloud Infrastructure capabilities over private low latency connections with no data transfer fees. So this is a list of regions where we have interconnect with Azure and interconnect with GCP. With OCI and Azure interconnect, we have 12 regions worldwide. 4 regions are in North America, 1 region is South America, 3 regions are in Europe, 1 region is in Africa, and 3 regions are in Asia Pacific. So total, we have 12 regions between OCI and Azure. And when we go with OCI and GCP, we have 13 regions worldwide. We have 14 regions. 1 is Gulf Cloud and 13 are commercial. So 13 are 3 regions in North America, 1 region in South America, 4 regions in Europe, and 5 regions in Asia Pacific. So we would be doing a demo for Azure and OCI Interconnect. You can connect an Oracle Cloud Infrastructure Virtual Cloud Network, VCN, with a Microsoft Azure Virtual Network, which is a VNet, and run a cross-cloud workload. In this typical use case, you can deploy an Oracle database on OCI and deploy .NET or a custom application in Microsoft Azure. These two virtual networks must belong to same company and do not have overlapping CIDRs. So Oracle Interconnect for Azure requires you to create an Azure Express Route circuit and an OCA FastConnect virtual circuit. So these are the list of components that are needed to establish interconnect between Azure and OCI. So on the Azure side, you need to have VNet, then the Express Route circuit, the virtual network gateway, route table, and network security groups. Similarly, on the Oracle side, you need to have VCN, which is virtual cloud network. You need to have FastConnect private virtual circuit, the dynamic routing gateway, route tables, and security lists or network security groups. So the prerequisite is that a primary pair of BGP addresses, one IP address for Oracle side, one address for Azure side, and a separate secondary pair of BGP addresses, one again for Oracle and the other for Azure. Please note, so while creating interconnect between Azure and OCI, by default redundancy is provided. So that is the reason you need to have two pair of IP addresses, one for primary and the other one for secondary. Moving on to have the interconnect with Azure. So these are the list of steps we would need to go through and establish the connection. So before going through live demo, I'll just walk through this, like why we need to have Azure portal and what we need to set up, and then what we need to set up on the OCI side. So first we need to configure the VNet and the security groups. Make sure what needs to be allowed. If you'd like to test ICMP, allow ICMP in the network security group and allow them. And then you need to set up the Azure Express Route Circuit. So why we need to set up the Azure Express Route Circuit first is that, so you need that service key to establish FastConnect in the OCI side. So you'll need to click on FastConnect in OCI and then select the partner as Microsoft Azure Express Route. And then when you proceed further, it will ask for a service key. Once you provide that service key, then you can proceed further in creating the connection. So that is the reason we need to complete the steps on Azure and then on the Oracle. So once that is done, set up the FastConnect Oracle virtual circuit and then confirm both the sides the circuits are provisioned. Once the circuits are provisioned, verify the routing has been done on the VNet for the route table, similarly on the VCN for the route table, then test the connection. So let's move on to the demo. So log into Azure console and then click on create a resource, then select networking. And then create the virtual network gateway. So provide the name, select gateway type as Express Route, choose a SKU as standard and click on provision the gateway. So once you're provisioning, it will ask for virtual network. So you can create the virtual network here by creating and defining the CID or block, or if you already have the virtual network created earlier, you can choose that virtual network while creating the virtual network gateway. So once the virtual network gateway is created, you can just click on, create. So once the virtual network gateway is created, so you can just go to a virtual machine, create a virtual machine of your choice. If you like to have Windows or Linux, you can have that image created in the same VCN where we define the VNet, where we define the CIDR. So you can have the CIDR for virtual network gateway. So that will be chosen while creating the virtual network gateway, and you can choose a subnet while creating the instance which you had created earlier. So once the instance is created, make sure you go to the network security group associated with that instance subnet and allow ICMP traffic. So once the deployment is complete, just go to the resource and verify whether the instance is running and make a note of the IP. So the next step is to create the Express Route Gateway. Selecting Oracle Cloud FastConnect as the provider. So while choosing the region, make sure which region you would like to have, and then provide the name for the Express Route connection you're going to create. Select the SKU, select the type you'd like to have, and then select the peering location and bandwidth. So it will take some seconds to create the express route. So once the express route is created, the validation needs to be done. And once the validation is complete, you can click on create. So it will take few seconds to create. And once the creation is complete, just click on go to resource and copy the service key. This is where the service key is provided, copy it and go to OCI console. And when you go to OCI console, select networking and navigate to FastConnect, choose a FastConnect partner and select Microsoft Azure Express Out as the partner. So provide the details and then select the DRG, which you had created earlier, select the bandwidth, then provide the partner service key. So like we told, two IP addresses, which we had predefined and as a prerequisite. So we'll be updating that and then click on provisioning. So until and unless the connection is up, it'll be in provisioning state. And once it is up, you can see it as provision and you can see two different logical devices for primary and secondary. And you can also see the BGP state up. So how to verify this connection? So the best way is to go to Azure portal and check what is the state of the BGP. So if the BGP is up, it means that the connection is up. Similarly, on the OCI side, you can just verify the connection was already up. And once the BGP is up, to verify like what kind of routing we are seeing, so you can just come back to OCI again, and then go to networking, go to dynamic routing gateways, and then click on auto-generated route tables for VCN attachments. There, you can see the live state provision. You can see the BGP status is up. Just go to the DRG, click on auto-generated route table for VCN attachments, and then click on get all route rules. So it will provide you the details of what routes are being learned. And you can see the 10.100.0.0/16, which is being learned from the virtual circuit, which is the Azure VNet CIDR. So this completes the live demo for Azure and OCI Interconnect, and I'll be handing it over to Sean.
Thanks so much, Ashantya. Really appreciate that. Okay, so this concludes essentially the three different agenda topics we had at hand. So just to summarize, to start, we went through some of the diverse connectivity options we had by showcasing the various OCI network gateways that can be used to secure and create private network connectivity within and outside of OCI from those virtual cloud networks we built out. We also highlighted the pros and cons of our different private connectivity options with both FastConnect and our site-to-site VPN service. And then we went through some multi-cloud integration techniques by exploring strategies for seamless multi-cloud networking between OCI and other cloud providers, going through either a FastConnect partner, IPSec VPN, or even Interconnect where available. So this completes majority of our presentation, and we do appreciate your time today. So we're going to review some additional resources that we have available from Oracle itself, so you can learn more about Oracle Cloud Infrastructure. So before we conclude, just want you to know that we do have a comprehensive certification program to help you become an expert in Oracle Cloud Infrastructure or Oracle Cloud Architecture in general. We have different learning paths available for you at our Oracle University portal. There's training material for exams such as our OCI Associate, Professional, Architect, and even Network Professional certifications, and many, many more. I'll have the links there available to you. Along with our certification paths, we also have additional free resources such as reference architectures, public documentation, and blogs for pretty much all of our different OCI services and features that we have today. And we also have hands-on learning material as well. And this includes OCI tutorials, our live labs, and even a free tier Oracle Cloud tenancy that's available to try out many of our OCI services. Along with best practice documentation as well, with our cloud adoption frameworks and video libraries available directly onto YouTube. Okay.
Awesome. Thank you, Sean. So if you enjoyed this session and would like us to conduct personalized training for you or your organization, please send us an email at our personal training email address and we'll reach out to you. Also, if you want to conduct a hands-on lab, we have some guided live labs called Quick Shot Labs we can take you through. We also have our Day One and Beyond series. So again, this is a session as part of that, and we're going to continue the series throughout the year. And then we also have a Code Innovate program. So with this, you can co-develop a solution based upon your own use cases. So please remember, personal training is an investment that Oracle makes for our customers to help them grow, develop, and learn new OCI skills. And this is provided at no extra cost. All right. So thank you, Sean and Ashintha, for an awesome session today. We really appreciate your time and help. Again, these cover OCI Zero Trust Packet Routing or Zipper on May 19th. So in the session, you'll be introduced to Zero Trust Packet Routing on Oracle Cloud Infrastructure. This is a newer service, definitely pertaining to security and networking, and how to start, building out your networks correctly with best practices. So with all that being said, thank you for joining today's session and have a wonderful day.
Essentially, LPG, DRG, and RPG for public connectivity or for private connectivity, whereas VPN, FastConnect are for private connectivity and not for public connectivity. Please confirm. So for this one, this question, yeah, the LPG, DRG, and RPGs, kind of a mix and match. So for LPGs and RPGs, essentially for private connection options. The DRG is a little different because kind of all encompassing. So it can for sure stand up private connections between VCNs or even other regions where VCNs may live, but it's also used for uh, private connectivity to on-prem or any other cloud providers. But yes, it is all private for those and essentially not for public connectivity. The FastConnect can be used for essentially a public peering. That's Ashanti covered it earlier, but essentially it's a private connection between your environment and us. That's correct. Okay, so I think that was it. So yeah, thank you again, everyone, for your time today. And yeah, we look very much forward to your feedback and future discussions and sessions. Thank you.